0.
Yeah. So 26 says find when this graph has horizontal tangents. Okay, so remember horizontal tangent means the slope of the tangent line is 0 because that's what a horizontal line is. So to find the slope of the tangent line, we need to take the derivative because the derivative tells us the slope of the tangent line, right? So we have 3x squared minus 6x plus 0. Then we need to figure out when is this slope equal to 0. So we set it equal to 0. And we can factor this, so that would take 3x out. We have x minus 2 left inside. So this is equal to 0. We set both of our factors equal to 0. And we have x equals 0 and x equals 2. So those are our x. Thank you. No, you're perfect. Thank you for the reminder. These are our x coordinates. We need to find our y coordinates because it says find the point and it's underlined. So it reminds us of that. So this is the x coordinate. We know if we plug it into the derivative, we're going to get out 0, right? Because that's the slope. But we're not trying to find the slope right now. We're trying to find the actual point on the graph. So we go back to the position function, which tells us the point on the graph. So we plug in 0, and we get the point 0, 3. And we plug in 2, 8 minus 12. -4 plus 3 is -1. Is that what you guys got? Let me plug those in.
-1 or -1.
-1. Yep. So those are our 2 points on the graph where we would have a horizontal tangent. Yeah? No?
So the one that, I mean, it's not on here, but my German test is undefined.
Oh, yeah. So undefined. You would often have something like cube root of x. Okay, so if you had something, if you're looking for when does it have an undefined tangent, remember that means that the slope, that the derivative is undefined, right? So that would mean the derivative has a domain restriction at that point. Okay, so you would see one like this. And this is a vertical tangent line because that's the slope of the vertical line is undefined. So if I derive this, I get 1/3 x to the -2/3, which I can rewrite as 1/3 times the cube root of x squared. I'm just going to I just rewrote that there. Okay. So here is a function that is defined on its domain. This has all real numbers as its domain, right? It's always continuous. Now we look at its derivative and we say, wait a minute, that derivative is not always defined, is it? There's a point that if I put in x, I would get out 0 on the bottom, and that's a problem, right? So the domain of this derivative is all reals except x cannot equal 0, right? If I put in 0, I would have a problem. So where is the derivative undefined? At 0. Since the derivative is undefined, the slope of the tangent line is undefined.
Can you find the point? Which, I mean, I know this one's 0, 0.
Yeah, if the function is defined at that point, yes.
But if it's undefined, can you find it undefined?
No, so oftentimes what will happen is your derivative is undefined where your function is also undefined, right? So like originally I was going to do this one, but that one's undefined at 0, therefore its derivative is undefined at 0. So typically, yeah, you can find the point. Remember in our homework, we had one that was like an ellipse. That's a really great one. And it had these vertical tangents at these points, and we did some implicit differentiation. And we found that these 2 x values are the 2 x values where the derivative was undefined. And then we plugged them back in and found 2 y values that, or I guess it'd be 1 y value that corresponded to those 2 x values.
So if you're going to find the y value, would you put it back into the function or the original function?
The original function, because we're looking for the point on the actual function. This tells us the position. This just tells us the slope of the tangent line. Does that make some sense? Okay. What else? Do you guys feel good with finding whether a piecewise function is differentiable?